Between humans and machines is getting thinner by the day. Boston Dynamics Atlas moves with such natural skill that it can run, flip, and even breakdance, while a robot dog in Sweden is learning to adapt like a real animal. At the same time, robots are now diving to extreme ocean depths, brewing coffee in busy kitchens, and even securing buildings with facial recognition. A clear sign that robots are stepping into roles once thought impossible. Let's talk about it. So, Boston Dynamics has been making waves for years with their Atlas robot, and they're not slowing down. Atlas has been showing off moves that seem almost human, though it's clearly built with advanced engineering. The latest videos show Atlas running with a smooth, natural motion. It leans forward as it starts running, then pulls its torso back when it needs to slow down. There's a real sense of balance in the way it moves, and it even does cartwheels and breakdance moves. What's really neat is how Atlas uses its swiveling joints. Its hips, waist, arms, and neck can all rotate 360 degrees. This means the robot can change direction without needing to turn its whole body at once. In one clip, you can see Atlas switching from a handstand into a round-off, and then standing up with its head turned backwards, which is just wild when you think about the engineering behind it. There's also some cool work coming out of China with a company called Unitree. Their G1 humanoid robot, which starts at a price of $16,000 US, has been upgraded to do side flips and even jogs now, after what they call an agile upgrade. You might remember that their earlier model, the H1, was the first of its kind to perform a backflip using electric motors instead of hydraulics. Even though the G1 is smaller and cheaper, it shows how different teams are pushing the limits of what humanoid robots can do. While Unitree's work is impressive in its own right, Atlas from Boston Dynamics has been in the game much longer and is still leading in terms of natural and dynamic movement. A big part of why Atlas can move so smoothly is the use of reinforcement learning. Basically, engineers run thousands of simulations where the robot tries different moves, and it gets rewarded for successful actions. Over time, it learns to perform tasks like running, crawling, and even doing a cartwheel more naturally. The process is a bit slow because each move has to be simulated and refined, but it's all about teaching the robot how to balance and adapt to different environments. Now, Atlas isn't the only project that's getting a major boost. Boston Dynamics recently teamed up with the Robotics and AI Institute, RAI, to take things even further. This partnership, which started back in January, is all about making Atlas's movements more dynamic and human-like by improving the way it learns in simulated environments. In these simulations, every time the robot performs a move correctly, it earns a reward, which helps it figure out the best way to move in the real world. Because of this approach, Atlas can now do a sideways roll on the floor, perform a handstand with more ease, and even do a cartwheel with better precision. The team's focus has been on making every movement safer and more efficient, something that's become really important now that many companies are working on using robots in practical, everyday tasks. Back in 2022, Boston Dynamics and a few other robotics companies agreed that their robots would not be armed, and that decision continues to guide how these machines are developed for industrial and public safety roles. Now, Atlas can bend its legs backward and recover from a prone position with surprising ease. It can also rotate its head and torso a full 180 degrees. These moves are made possible by combining reinforcement learning with advanced models that let the robot adapt to more complicated environments. For example, the robot can reach into cluttered spaces or navigate around obstacles without missing a beat. The technical side of all this gets even more interesting when you look at Boston Dynamics' collaboration with